Hey, Education Box here. Welcome back to another video. In this video, we will be going over the index laws. So, no matter whether you're trying to learn all of the index laws or you're going to use them in other concepts, this will be very useful. So, I'm going to state all of the index laws and explain them later in depth. And just a side note, I'm going to use the exponent variables as m and n, as that's what they're commonly used as. So, the first index law states that a to the power of m times a to the power of n is equal to a to the power of m plus n. Our second index law states that a to the power of m, in brackets, to the power of n is equal to a to the power of m times n. Our third index law states that a to the power of m divided by a to the power of n is equal to a to the power of m minus n. And just some handy things to look out for is if you have a negative exponent. So, if you have a to the power of negative m, it is equal to 1 over a to the power of m. And if you have anything to the power of 0, so for instance a to the power of 0, it will always equal to 1. And if you have a fraction as the exponent, so like 1 to the power of 1 over n, it will equal to the nth root of a. Okay, so now let's go into depth of these laws. So, let's take a look at the first one. It states that a to the power of m times a to the power of n is equal to a to the power of m plus n. Now, let's take an example. Let's say I have a to the power of 3 times a to the power of 2. Now, what that basically is saying is you're doing x times x times x times x times x. So you're multiplying x 3 times, and then you're multiplying it by x multiplied by itself 2 times. And if you can see, we're multiplying it by itself 5 times, and that is why it is equal to x to the power of 5. So basically, we have x to the power of 3 plus 2, which basically means that we're adding them to get x to the power of 5, and this would work for any value. So our second index law stated that a to the power of n, in brackets, to the power of m is equal to a to the power of n times m. So let's take an example. Let's say we have x to the power of 2 all to the power of 3. That basically is saying, in expanded form, that we're doing x to the power of 2 times x to the power of 2 times x to the power of 2. Now, if we use our first index law, we know that if we are multiplying two indices, we have to add them. So that would come to x to the power of 6. And from here, we can notice the shortcut that you're just multiplying the indices. So in this case, 3 times 2 is equal to 6. So let's take an example. So let's take an example of 2x to the power of 4 all to the power of 3. Now, this is a bit of a complex example. However, it is pretty simple. So what we need to do is we need to take each element in the bracket and put it to the power of 3. So basically, we will have 2 to the power of 3. And since we have x to the power of 4, we know that our law states that we have to multiply the indices. So 3 times 4 is 12. So we have 2 cubed times x to the power of 12. And if we do that, it comes to 8x to the power of 12. So now let's go into more depth. The third law states that a to the power of m divided by a to the power of n is equal to a to the power of m minus n. So let's take an example. Let's say we have a to the power of 4 divided by a to the power of 2. Now, what we can do is we can write this in expanded form. So you can write it as a times a times a times a over a times a. Now, when we cancel the a's out, all we're left with is a times a, which is a to the power of 2. And from here, we can notice the shortcut, which is basically subtracting the indices. So in this case, 4 minus 2 is equal to 2. So the answer to a to the power of 4 divided by a to the power of 2 will be a to the power of 2. So our fourth index law stated that a to the power of negative m is equal to 1 over a to the power of m. So now you may be a little bit confused. So let's take an example of x to the power of 3 divided by x to the power of 5. Now, even though this isn't a negative indice, we can see that if we write this in expanded form, it comes to x times x times x, all divided by x times x times x times x times x, which is x 5 times. And if we cancel the x's, we are left with 1 on the top side and 2 x's on the bottom side, which means we have 1 over x to the power of 2. And using our second rule, we can see that x to the power of 3 divided by x to the power of 5 is equal to x to the power of negative 2. So we can also see that 1 over x to the power of 2 is the exact same as x to the power of negative 2. So in a general case, we would just have to put 1 over and then that number and remove the negative symbol. So our fifth index law stated that a to the power of 0 is equal to 1. So now you may be a little confused. Well, how can any number to the power of 0 equal to 1? So let's take an example of x to the power of 3 divided by x to the power of 3. Now, knowing our basic division, we know that any number divided by itself is equal to 1, because we can just cancel them out to get 1. Now, we can also say that x to the power of 3 divided by x to the power of 3 is equal to x to the power of 3 minus 3, which is equal to x to the power of 0. So this shows that x to the power of 0 is also equal to 1. So that is just one way of proving that. So our sixth and final index law stated that a to the power of 1 over n is equal to the nth root of a. Now you may be a little confused. So let's take an example of 16 to the power of 1 over 2. So 16 to the power of a half. Now, since we need to take the nth root of that number, which is 16, and n would be 2. So that would be the square root of 16, which is equal to 4. So 16 to the power of half is equal to 4. Now you may be wondering, well, can we do this with other things? What if we have a numerator that is greater than 1? So let's take the example of 27 to the power of 2/3. Now what we need to do is we need to take the nth root of that. So that would be the cube root of 27, which is equal to 3. And that 2, which is the numerator, will actually be the squared in that number. So we would have to square 3 to get 9. So 27 to the power of 2/3 is essentially the cube root of 27 squared, which is equal to 9. Okay, so let's get into a few examples. Let's say we have 3 to the power of 6 times 2 to the power of 4 divided by 3 to the power of 4. Now we can also write that as 3 to the power of 6 divided by 3 to the power of 4 times 2 to the power of 4. Now, using our second law of indices, we know that if we're dividing two indices, we have to subtract them. So 6 minus 4 is equal to 2. So what we're left with is 3 to the power of 2 times 2 to the power of 4. So in our second example, we have 3 to the power of 2, or 3 squared, times 3 to the power of a negative 5. Now, using our law of indices, we have to add them together. So 2 plus negative 5 is equal to negative 3. So then we're left with 3 to the power of negative 3. And we know that if we have a negative number, we have to put 1 over that number and then take away the negative symbol. So that would come to 1 over 3 to the power of 3, which is basically 3 cubed, which is 27. So we're left with 1 over 27. In our final example, we have a to the power of negative 1 times the square root of a. Now, how would we simplify this? Well, we can also write it as a to the power of negative 1 times a to the power of a half, since the square root of a number is also that number to the power of a half. So then, we can also write that as a to the power of negative 1/2, because anything multiplied by 1 is itself, so it's just negative a half. And then, from there, we can now write our answer as 1 over a to the power of a half, using our negative indice law, or we can write it as 1 over the square root of a. Okay, so let's take a few more examples to really strengthen the idea of these laws. So, let's say you have 4 to the power of 2 times 4 to the power of negative 3. Now, by our law of indices, if we're multiplying two indices together, we have to add them. So, 2 plus negative 3 is negative 1. So, we get 4 to the power of negative 1. And if we have a negative indice, we know that we have to write 1 over and then remove the negative symbol and then write that. So, then we have 1 over 4 to the power of 1, which is just 1 over 4. So now let's say we have in brackets y to the power of 4, all to the power of 6. And we know that if we have an indice in brackets and an indice outside of brackets, we have to multiply them. So 4 times 6 is 24, so we get y to the power of 24 as our simplified answer. Then finally, let's say we have 32 to the power of 3 over 5. Now we know that that can be also written as the fifth root of 32 cubed, or to the power of 3. So the fifth root of 32 is 2, and 2 cubed is 8. So the answer to that will be 8. So that will be all for today's video. Just a quick recap. The three main index laws are that if you're multiplying two indices together, you have to add the indices. If you're dividing two indices, you have to subtract the indices from each other. And if you have an index in a bracket and then another index outside of the bracket, you have to multiply the indices together. So that will be all. And as always, thanks for watching.